Okay, student, good morning. Today we are going to continue our discussion on chapter 6. So in chapter 6, our focus is multiple cash flows. Right. I like to highlight cash flows. That means we have several cash flows. In chapter 5, we discussed a special case, just one single cash flow. Chapter 6, we have multiple cash flows. So we can calculate the present value and the future value for multiple cash flows. Right. Then we discuss a special case, annuity. When I see the annuity, I know it's a constant cash flow, right? Annuity. Then perpetuity, the constant cash flow forever. Right? So our next topic is periodic payment, number of period, and interest rate. Right? So the best example is the house loan. Right? So when I think about house loan, I can see multiple cash flows. Right? So I like to know the payment, the periodic payment of the house loan, the number of period of house loan. I mean, how long the borrower can pay off the loan. Right? Finally, the interest rate of the house loan. Right? So follow our PowerPoint slide. Next slide. So to calculate the first, we discuss finding the value of periodic payment, right? Like the payment for the house loan, right? So to calculate the periodic payment amount required to pay or receive a certain dollar amount. So it's a very common problem in finance in determining the payment schedule for a loan on a consumer asset, such as a car, a home that is purchased on credit. So to solve the problem on the financial calculator, take just a few seconds once the timeline is prepared. So for me, timeline is important. All right. So in our test 1, we have section B, long answer question. I will require student to draw the timeline. Right. So timeline is the key. So let me give you my handwritten note here. So in our previous discussion, we know how to calculate the PV or FV of the annuity, right? Given P&T, I, and N. So in our previous discussion is to find PV or FV given P&T, I, and N. And I know they have a relation, right? By given any three of them, we may know the force. That's all. So now we are going to find the P&T. For example, the periodic payment for the house loan, given PV, I, and N. So the point is to draw the timeline, right? So this is our example. So you have just purchased $45,000 apartment, and you were able to provide a deposit of $50,000 to obtain a 25-year home loan at 8% for the balance. What are your monthly payment? So again, first address the timeline. So you need to borrow money for your apartment, right? The house is, or the apartment, $45,000. And you have deposit of $50,000. That means you will borrow. So how much money you have to borrow today? $45,000 minus $50,000. So you borrow $400,000 today. So draw the timeline. You can see $400,000 today. This is the amount you borrow today. Then 25-year home loan at 8%, right? So you can see the number of years, 25, the red, 8%. But there's a key point, monthly payment. So you have to adjust your data according to the payment frequency. All right. First, 25-year monthly. So 25-year months, you have 300 months. All right. Then the rate 8% is for 1 year. Monthly rate 8% divided by 12. All right. So here, let me show you my handwritten note. This is the P. The rate is 8% divided by 12. This is a number. Number of period, 25 years times 12, 300 months. All right. So I have all the information on the timeline. Now, calculation for me is not a problem. You can either use a formula or Excel. Right. So Excel will give you the number here. I will show you the Excel example later. By formula, it's all right. So you can do the calculation by your hand using the formula. So you can see this is our annuity formula. Right. So we just enter the input variable, $400,000 PV. Cash flow is the unknown variable. I is here. Number of period 300, right? Then we move all the number to the right hand and the unknown number or unknown variable to the left hand. This is our final result, right? Excel, yeah, we can use the PMT formula in the Excel to do the calculation. So this is our example. So you are going to borrow $25,000 to buy a house. What will your monthly payment be if the interest rate is 0.55% per month and you borrow the money for 30 years? All right. So again, Excel, we will discuss the Excel later, but the point is to draw the timeline. First, the interest rate, 0.58%, right? 0.58% per month. So this is a monthly rate already. You don't need to do any adjustment further, right? But the number of period, 30 years. So 30 years, our monthly payment, so 30 years. Number of period will be 30 times 12. This is 360. Right? Present value, you borrow $250,000 today. Right? So I draw the timeline. Present value today. And the rate, the number of period. Now I want to know PMT, periodic payment. Right? So you can use the PMT formula in the Excel, and this is the number. So I have a note here. The payment is negative. The idea is simple. Outflow. So you borrow the money today. This is inflow. PV is positive. PMT, monthly payment. Outflow, negative. All right. So PV and the PMT, they have an opposite sign. One is positive, the other is negative, right? Okay, so next slide, finding the number of payment. So if you understand the concept, so you can see the idea is simple. So let me show you my handwritten note here. So we have 4 variables in the annuity, right? So in our previous discussion, we discussed how to find a PMT. Now we want to find the number of payment, that is N. All right. So you can see our final variable will be I, finding the interest rate. Right. Okay. So this is our example. So the number of payments. So number of payment tells us the time required on an annuity contract to repay a debt. Right? So this is our example. You decide to purchase a motor vehicle for $35,000 and you agree to pay $700 per month the bank charge an annual rate 7.42%, right? So if the compounding frequency is monthly, how long will you need to pay off the loan? All right. So I highlight this word monthly. So again, you have to adjust your data according to payment frequency. So you can see here, my handwritten note, you borrow $350,000 today. This is PV. Your PMT, $700. Your rate, 7.42%. But 7.42% is annual rate, 1 year rate. So monthly rate will be 7.42% divided by 12, right? And I know I have a timeline. Now we want to find the number of periods, right? So again, you can do the calculation by the formula. So this is a calculation by the formula. And you can see we have the annuity equation. Then we enter the input number to our equation. So PV, CF. Now we want to know the number of period, that is N, right? So the calculation will be not easy, all right? And you can see this function ln. ln is natural log. But I don't want to spend time on that because this is not necessary, all right? So in finance, our focus will be the concept. So for me, timeline is important, right? If you can draw the timeline and identify the amount and the timing of money, for me is enough. Then you know how to use the Excel or financial calculator to do the calculation. So let's use the Excel, all right? So your $35,000 for motor vehicle, right? Today, this is a present value. And your payment, $700 per month. The rate, 7.42%. How long will you need to pay off the loan? So let me show you my handwritten note first. So when you do the calculation, I will ask the student to draw the timeline. Right. So in this example, PV $35,000, PNT $700 every period or every month. Right. The red, please know you have to convert the 1 year rate. 7.42% is 1 year rate. Monthly rate, 7.42% divided by 12. All right, this is the number. Now we want to know the number of period. So you can use the Excel to do the calculation after you have a timeline. We use the number NPER formula, right? This is number 60 months or 5 years. Please know this number is months, 60 months. All right, if you want a year, you have to convert 60 months to year. 5 years, all right? There's a note. So you can see I put the PMT, the negative sign before the PMT, right? So idea is simple. PMT and the PV, they have an opposite sign, all right? So this is the key. If you don't follow the sign convention, the result will be incorrect, right? You can try yourself. So PMT, negative, PV, positive, right? So you can see the next topic is finding the rate, finding the interest rate. So again, let me show you the concept. So annuity, we have 4 variables. Now we want to find the I, interest rate. Okay? So you can see why we have this issue, finding the interest rate. So for me, interest rate is a return to the investor. It's also the cost to the borrower, right? And I know interest rate is an exchange rate between today's money and future money, all right? So finding the interest rate, example. So your parents are getting ready to retire and decide to convert some of their superannuation into an annuity that guarantee a fixed annual income. So their fund manager asked for 35,000 for annuity that guarantee to pay them 50,000 a year for 10 years. So what the rate of return on annuity? Sorry. Okay, the question is very long. The point is now you have to show all the information on the timeline. All right. So they asked for $350,000 for the annuity. So 350,000 is the present value. All right. So your parents need to deposit $350,000 today. Then the fund manager will provide them or pay them 50,000 every year for 10 years. So we have 50,000 is a payment for every year, right? 50,000 to year 10, right? Then our question is, what is the return on the annuity? That is the I variable. All right. So we draw the timeline and show the information on the timeline. And I know the non-variable PV and PNT, number of period. Now we want to know the I, the return. Okay, so you can do the Excel, do the calculation using the Excel, this is the number, or you can do it by the formula. So let me show you how to do that by formula or by hand using the formula. So again, this is our annuity equation. So PV, 350,000. Cash flow, payment, periodic payment, 50,000. Number of period, 10. Now we want to find the I variable. Right? You will see it's impossible to find the I variable directly if you do the calculation by your hand. All right. So we use the method. The method is trial and error. Right. So trial and error here. Let me show you how we do that. Okay, we can try interest rates 7% first. All right, we try 7% first, and we have the present value. It's around 351,000. Over 350. Right, our PV should be 350,000. Then we try higher rate, 0.071. Right, then we have present value. It's around 349,000. All right, so this is our conclusion here. When we use 7%, the PV is too high. When we use 7.1%, right, the PV is too low. Therefore, I know the interest rate will lie between 7% and 7.1%. Right. So our next step is to try 7%, 7.05%. I mean, 7%, 7.1%, the average is 7.05%. So this is a trial and error. But I just let you know the concept. I don't suggest this way because this will be very time consuming. All right. The question one is, how can we know the first interest rate, 7%? Right? So it's difficult. Right? So we don't. I think we don't need to use this method. All right. You just know we have trial and error. So the best way is to use Excel or financial calculator. Right. So this is our Excel example. Right. So again, I show the information on the timeline. Right, so present value $350,000 today. PNT 50,000 every year, 10 year, number of years, 10 years. Now we want to find the I variable, interest rate. Okay, so after we have the timeline, then we use the rate formula in the Excel. The number is 7.07%. Again, I like to highlight the negative sign before the PV. All right, so PV and the PMT, one is negative, the other is positive. All right, in this example, your parent, right, deposit $350,000 today, so this is an outflow, and receive 50,000 every year inflow. All right, so you can see one is negative, the other is positive. Right? Okay, we finished the discussion on this topic. So periodic payment, number of period, and interest rate. So let's review the key concept for our student. So I know we have 4 variables in our annuity, right? So and we have 4 variables, they have a relation. I don't copy the formula, right? Please refer to our PowerPoint slide, you can see the formula. So they have a relation. In the relation, we have PV or FV, PMT, I, and N. So now we can find periodic payment, interest rate, or number of period. Good example is house loan. Right? So we can find payment given PV, I, and N. And we can find the number of payment given PV, PMT, sorry, this I, right? And finding the rate given PV, PMT, and N. So again, I like to highlight the importance of timeline, right? Okay, so we have one final topic for today's lecture, EVA and APR. So interest rate is an important variable. Now we are going to discuss 2 interest rates. One is EAR, the other one is APR. Right? So we will discuss the difference between that. Right? This is a key. So annual percentage rate, APR. This is annual rate that is called by law on all loans. So you can see the house loan, right? The rate you can see in the market is annual percentage rate or APR. If we have APR, we can calculate the period rate. The period rate is APR divided by number of periods per year. For example, APR 12%. What is the monthly rate? Monthly rate will be 12% divided by 12, 1%. All right. So APR and the period rate, I think it could be easy to understand. Now we discuss another rate, EAR, effective annual rate, EAR. This is an actual rate paid or received after accounting for compounding that occur during the year. All right. So the EAR consider the compounding. What's the compounding for me? That means money can earn money. That's a compounding. So if you want to compare 2 investment or loan with different compounding periods, you need to compute the EAR and use the EAR for comparison, right? Because the EAR is the actual rate paid or received after accounting for compounding, all right? So let me show you the detail about the EAR. In the market, you cannot see the EAR. In the market, you can see APR. What you see is APR. This is not EAR, all right? To have EAR, you have to do the calculation. So this is our EAR formula. So EAR is here. Right? This is our formula. So APR over M, 1 plus APR over M with power of M minus 1. Right? M is the number of compounding periods per year. For example, monthly, M is 12. Right? And remember, APR is a core rate. I mean, in the market, the rate you see in the market is APR, not EAR. All right. So how we have this formula? So again, let me use an example. So this is my example. Let's consider a simple case first. M equal to 2, right? So that means semi-annual, right? So if you have compounding every 6 months, right? So APR is M. So APR is a 1-year rate. So semi-annual rate will be APR divided by 2. All right. Then you have 2 periods, 1 and 2. Now let's consider you have $1 today. So you initial investment $1 today. After 1 year, how much money you have? So you have the $1 times 1 plus the rate. Please note, semi-annual. So semi-annual rate is APR divided by 2 with power of 2 because now we have 2 periods for 1 year. This is a money at year 1. And your EAR will be the money at year 1 minus your initial investment, $1. So this is our EAR. Right, this is a special case, right? M is 2. Now we consider a general case, M. So M could be any number, right? Monthly, 12. Daily, 365, right? So the idea is money at year 1 is here. 1 plus period rate with number of periods, right? So our EAR will be the amount of money at year 1 minus the amount of money at year 0 divided by initial investment, the amount of money at year 0. And this is the result. Right. So for me, this formula is understandable, right? So if you know this timeline, okay. So please know the rate you see in the market is APR. It's not EAR. When you compare 2 investments or 2 loans, right, you use EAR for the comparison because EAR you can see EAR consider compounding effect, and we need to consider compounding effect because money can earn money. All right. So next slide. This is our example. So you are looking at 2 saving accounts. One pay 5.25% with daily compounding. The other pay 5.3% with semi-annual compounding. Which account should you use? So I highlight a few keywords. Saving. So you are the saver. So for you, the rate is return, right? And we know we should choose higher return, right? Higher return. So 5.25% versus 5.3%. You might say 5.3% is a higher return, but please know 5.3% or 5.25%, this is APR, right? So in the market, you can see the APR. That is not EAR, right? So you have to do the EAR. And to do the EAR, you need to consider the compounding frequency. So first account, daily. Second account, semi-annual. So we do the calculation. First account, EAR, daily. So you can see the number, 365, right? This is the EAR, first account. Second account, EAR, semi-annual. So you can see the number of 2. That means 1 year, 2 semi-annual periods. All right. And this number is here. So second account, the EAR is lower. So which account you should choose? The answer is first account. Right? So you can see the point is we need to use EAR rather than the APR. Right? So next, let's verify the choice. Right? So we choose the first account. So let's see. This is our calculation. So suppose you invest $100 in each account. How much will you have in each account in 1 year? So first account, number of periods 365 because of daily. Right? So number of periods 365. The rate 5.25% divided by 365. Again, the reason daily. PV $100, you invest $100 today and compute the future value. This is the number. Second account, semi-annual. So number of period 2. The rate 5.3% divided by 2. Semi-annual rate. Present value $100. Compute future value. This is number. And you can see the number in the second account is smaller. Right? So you have more money in the first account. Right? The reason? Compounding. Right? Compounding effect. All right, this is example 1. We have next slide. We show you the effect formula in the Excel. Right? So Excel can help us a calculation. So you can see you use the Excel formula. Excel formula is here. So first input variable is APR. Second input variable is number of periods per year, right? So I used 5% for APR. Then frequency, we have different frequency from annual to daily. Number of period per year. Then we use the effect formula in Excel, and you can see the EAR. Right? So daily, it's very clear if the APR is 5%, right, a constant. EAR, the higher EAR for daily compounding. Right? I think we have money to earn money every day. Right? So if you are the investor, daily is better. Right? However, if you are the borrower, so if you are the borrower, the rate is a cost to you. You have to choose lower rate. So daily will not be a good choice. Right? So we have one more question. Saving, borrowing, and arbitrage. So when I see the arbitrage, that means we can borrow the money at a low rate, save the money at a high rate. Arbitrage, make money with no risk. So let's take a look at the example. So we have 4 banks. Their APR here, they have different compounding frequency. A, annually. B, monthly. C, weekly. D, daily. So if you want to borrow the money, which bank should you choose? If you want to save the money, which bank should you choose? Is there arbitrage opportunity? If yes, how? Right. And if we are the arbitrage opportunity exist forever, and why? Right. So this is an advanced question. So let's do the question together. So the first point is we should use EAR rather than APR. Right. The rate you see on the slide or in the market, they are APR. Right. They are not EAR. Okay. So you can use the Excel effect formula to do the EAR calculation. And the arbitrage is to borrow the money at a low rate and invest the money at a high rate. This is arbitrage, right? So let's do together. So you have 4 banks, their rate, APR rate, right? Now we calculate the EAR, right? So I enter the information to the Excel. So we have different frequency, different APR rate, right? Then we convert APR to EAR, right? By the way, this example is available on our Moodle page, all right? So we have the EAR. Now our decision is simple. If we want to borrow the money, we will choose the lower rate. So you can see the EAR here is lower, right? Okay, so we choose the bank D, right, at a lower rate. If you want to save the money, you choose the higher rate. So bank B, the higher rate, right? Arbitrage, that means you can borrow the money at bank D, lower rate, plus saving the money at bank B, a higher rate. Okay, so will the arbitrage exist forever? The answer is no. Arbitrage opportunity will disappear very quickly. So let me show you my note here. The reason is here. When you borrow the money at the low rate, so more borrowing, the low rate will go up. On the other hand, if you invest the money at the high rate, more saving, the higher rate will go down until balance. All right, so arbitrage opportunity will disappear immediately if the market is efficient. All right, okay. One more point for you. So some students might think the arbitrage is interesting. We can borrow money and invest money and make money with no risk. However, in practice, we like to highlight the transaction cost. So in our lecture, our discussion, we do not consider the transaction cost. The transaction cost is a bid and the ask rate. So I don't want to spend too much time to discuss the terminology about bid and the ask. The idea is the bank will give you 2 rates. If you borrow the money, you need to pay a higher rate. If you save your money or deposit your money, you receive a lower rate. This is the bid and the ask, right? Ask is higher rate, bid is the lower rate. All right. So for example, in our calculation, you might see EAR is a 1 number, but in practice, it's not. It's a range, right? If you consider the transaction cost. And if it's a range, we have the overlapping area here, right? So it's impossible for you to do arbitrage in practice if we have transaction cost, right? So given the transaction cost, your rate is not just a number, your rate is a range. The idea is if you borrow the money, you need to pay a higher rate. Invest the money, you receive a lower rate, all right? Okay. So we finished the discussion. This is the final topic. So again, let's review the key concept for you. So in this topic, we address EAR versus APR. So when I see the APR, I know this is the state for interest rate, right? So in the market, the rate I see is APR, but the rate APR is the rate before considering any compounding effect. For example, APR 10%, we do not consider compounding effect. Then EAR, effective annual rate. So EAR is a rate on an annual basis that reflects compounding effect. For example, 10% compounded quarterly the EAR is 10.38%. All right, so EAR will be higher. Right? The idea is money can earn money, right? When we discuss arbitrage, arbitrage is borrow the money at a low rate, save the money at a high rate. We use the EAR to make the decision. All right. When we want to make a comparison, we use the EAR rather than APR. But there is a note here. When we do the time value of money calculation, we don't use the EAR, right? When we do the calculation, time value of money calculation, we use the period rate. Period rate is APR divided by the number of periods per year. Right. So EAR is for comparison purpose. Right. It's for the comparison purpose. When we do the time value calculation, time value of money calculation, we use the period rate. Right. Period rate is APR divided by N. All right. Okay. I hope students now you know the difference between the APR and the EAR. Like two more things to do. First, I show you our Moodle page. Okay. So today is our last lecture before our study break. I want to say thank you for your engagement so far, and hopefully you have a very good, nice study break. But one more thing I want to say, I'll remind you, we have the test 1 after the teaching break. Right. So let me show you our test 1. Okay, so it's a reminder. So I hope students can use the study break to review what we have learned over the past 6 weeks. So test 1 will cover chapter 1 to chapter 6, and it's the day for our test 1. Please note the time, 6 p.m. Is not regular school hour because we want to avoid the clash with other paper, right? There's a reminder, our test, we have 2 sessions. Session A will include 12 multiple choice questions. I think this part will be okay for our students, just like your quiz. Right? But please know, we have some setting in our multiple choice question. For example, you cannot go back to the previous question, right? Session B is important. It's about 70% of the test, right? We have 3 long answer questions for session B. So student, you need to handwrite the answer. For me, timeline is important. So I will ask the student to hand draw the timeline. All right, so this part is important. And you have to upload a single PDF file to our Moodle page. Right, we have some tip for you about how to prepare the answer in a single PDF file. But student, you might have your own way to do, to handwrite the answer and to screenshot. It's fine. Just give you one example. So this the sample question from previous student, our past student. So you can see the point is here. You need to draw the timeline and address the input variable, right? And what the variable is unknown, right? So you can use Excel to do the calculation. It's fine. The student also show the detail of the formula. It's fine, right? But for me, the timeline is important, and what is a non-variable, what is unknown variable, all right? And for the EAR, you can see we have different bank, right? So how to calculate the EAR. So the point is, let me know you understand the concept behind the formula. All right. So this is our test one. We have the sample of the handwritten answer on our Moodle page. Please take a look. All right. So one more thing to do, attendance recording. Let me show you the QR code. Right, student, now you can use the QR code to record your attendance today. Right. So thank you again for your engagement and look forward to seeing you in 2 weeks. Have a nice study break.